Welcome to the Model 23 Supervised Machine Learning Regression. In this model, we will present the concept of neural network regression. In order to have a clear understanding about the neural network regression application, we will take a look on the case study of the compressor shaft vibration regression. As usual, we have different uh, definition that we apply in machine learning, such as artificial intelligence, machine learning, unsupervised machine learning, supervised machine learning, and the different type of supervised machine learning that are supervised machine learning classification and supervised machine learning regression. Consider different technologies and methods that can be applied on the field of artificial intelligence. We'll focus on this training in machine learning and later on in deep learning. The concept of machine learning, as we already discussed before, is just to use a data set that can be data that came from a sensor or even data as a result of non-destructive tests. And we are using this data, split this data in training data sets and test data sets with the predefined model. In this case, we are considering the neural network. Then we use the 70% of our data sets training data for the model learning. So that's we call training learning. And then, of course, after learning process, the model will predict an error based on a training data set. And what we're going to do is to input the test data in the model that we training with the training data set and check the error that is produced by this model. Since this error is acceptable, what we are going to do, the next step is to come out with a new data set, and then with such new data set, what we can do is to apply to the model, and based on the error, if the error is acceptable, we are validated. Now we apply the same principle that we had for the that we have in machine learning, but in case of regression methods, what we are now doing is to predict the future independent, let's say, dependent variable that is, let's say, a continuous variable such as time to failure, remaining useful lifetime, and or other parameters, whatever you want to predict. But to do that, we need to know previous data and split this data set that are previous data with such information that we want to predict. Split this in that training data and test data 70-30%. Define one regression model. We can use a neural network, then use the 70% training data to uh, adjust this model to this data. Then, of course, we verify how the model is good based on the other 30% of the test data. And then, of course, in the end, if the error is acceptable, what we're going to do is to use a new data set and validate the model. Okay, so let's go to understand the regression method. We have different type of supervised machine learning regression. The neural network regression is one of the methods, but we also have different other methods. And the way to know basically which are the best method that fits in our data is to compare the error that's each method produce. The one that have the lowest error in the end will be the best method that fits in our data. What we've got from a supervised machine learning for this neural network regression are the the regression line that better fits in our data, and it's very good that this model shows the one regression line for the training data set, for the test data set, for the validation data set, and for all data together. Then we can use this equation here that make the relation between the output and the targets to find out our method. So when we use a neural network for regression, we have the same concept of we have in general a neural network. So we have neurons, input neurons, output hidden layers and output layers. In this case, to make a simple example, we have only input layer and output layer. but the idea is that such neuron, input neuron, will pass information for the output neuron. So here we have the vector x with information, we have waves, and we have the function, this output function here, and that output function in the end is the function that we want to use as a regression function. So let's take a look how does it works. We can represent this function in a matrix way. So we consider uh, uh, a matrix for the wave, each wave that we have um, in our neural network, and we have the points that we use in our neural network. And the end, of course, we will have here our functions that we use as regression. Very important points that the wave are initially defined as randomically. So that's we have a random values for the wave, and as long as we're going through the neural network by multiplying the wave by the input data and gets and calculates the error, we'll have the back forward process to adjust the wave based on the error that we've got. So that we have similar that we have in classification methods. So in the end, what we want to do is to define the functions that better fits in our data. The function that better fits in our data sets are the one that have the minimal error. So how I calculate this error? So usually what I want to minimize is the difference between the output that I've got from a model and the targets that are already predefined. That's why I need to have different simulation of neural network, feed forward process and back forward process to adjust the waves. And in the end, I will start to test different functions that better adjust on my data is the one, and in the end is the one that have the minimal error. Okay. So let's take a look on example to understand how we apply that in practice. So we have an example of compressor shafts here. We have three different level of degradation in compressor shafts concerning vibration. So here we can see different level of vibration. Here we have degradation progression signature, and here we have remaining useful life. So that is our data set that's already calculated by using these three compressor shaft vibration measurements. So that I have in the past, and now I want to create a model that enable me to predict the new values of remaining useful life of shaft vibration. So by doing that, I have to build my neural network. So in MATLAB, of course, this is automatically done, and I just need to I can modify the number of layer hairs, hidden layers, or and configure my to have a little bit different configuration of my neural network. Okay. So another very important concept that we have in neural network is the number of epochs, and epochs is a complete training that we have. So here in this x-axis shows how many epochs, how many training we have, and the objective of training again and again the neural network is to achieve the minimum error. So we have here in this graph different lines in different colors that each color represents one data set. So the blue one is for represent the training data set, the green one represents the validation data set, and the red one represents the test data set. And we have what we call best. That's the software already tells you which are the best number of simulation when you achieve the minimum error. So we can see when we look on the validation data gets in the 5 number of epochs. So that means 5 times they feed forward, get the input from the input vectors, consider the wave, given our output, calculates the error, forward backed, based on the error calculation, they calculate they updated the wave, and then again with the same inputs they go feed forward. They do that 5 times and they get the minimal error. Whenever we updating the waves, we change the output value, and the output value getting closer to what we have as a target. So this graph shows that when consider the validation data set, The 5 is the number that we've got the minimum error. So if I go back again, I will not reduce the error. So I'm losing time my simulation by doing that. So similarly, if I look onto other plots, for example, this blue one is the training data set. The training data set, the error is reducing. When we get in 11, I've got the minimum error that I can achieve. So there's no reason to go further and updating to go for more simulation, feed forward, back forward to update the wave and minimize the error that I have here. And then of course I have another curve here for the test. That's I achieved the minimum error is 11, similar that's what I have for the training, and that all of them were described in sync. Yeah, and the validation is here, the test in here. So the test is interesting because I already have one point that seems to be minimal, but in the end, after make some simulation, I achieve the other point that's a little bit minimum. So if I were consider only the test that I said, I would stop here because different from this point and this point in terms of error are minimum. But of course, I consider difference data sets, the training, validation tests, and I need to consider all of them. Okay, that's a very important concept. But in the end, what I get is the I called the regression. So the regression is an equation, a linear equation that shows the relation between output and targets. Then I can use this equation to predict the new remaining useful life. So that's basically what I've got. And if we look on the correlation factors that I have here, they are close to 1. So if I look on the validation and test data sets, they are very close to 1, but I need to consider also that I have 3 points, only 3 points here. So it's simple to adjust this line, and these points are very well adjusted to one line. But if I consider all the 70% of data set, that's a higher sample of the data set, or even the whole data set, I got a good correlation. So the idea now is to use to predict a remaining useful life by using the targets. And then of course, if I get one of these on one of these regression equation, though, let's consider the training data. Now I can predict the remaining useful life based on the real targets that I have as remaining useful life here by use this equation. So I can predict remaining useful life for 21 days, depends on the level of RMS that I have. And of course, for each level of RMS, I have a level of remaining useful life. And then I can make this relation, look on it on my data sets, and predict my future remaining useful life. And that's what I've got from here when I have this information in here, and then I will start to let's say predict for a new equipment remain useful life for the next time based on degradation. Okay, so let's take a look how does it works in a MATLAB. That's very important to see how you can do that in practice. So to use the MATLAB, you need to open the MATLAB software and go through the application of a network. So let's take a look on how does it work. So here we open our network now applicative. So here we have different applicative of network. The one that you use to regression is this model here. So we need to go further import our templates information. So basically what we now doing is to get our regression feed forward neural network. We go to case study, then we got our first data set. So here we need to import our data set so we can see the level of vibration of the compressor and the degradation level. Then we accept the data, just put in a rules format. Then we go back and now we got again the data, but basically what we've got is the results, the targets that we want. So those are the target remaining useful life that we want to predict based in this vibration and degradation progression signature. So I finish now. So what I'm going to do now is to go to the first step. We can see how I split the data. This tool already selects 70% of my dataset for training, and then I have the freedom to choose how much I want to test and validate. I let what the software already set up. Then I go for a next step. Now, as we had saw before, we had already the input layers based on the data sets we input in the file, and the software self-organize the layers. So what I have here, as I mentioned, I have one output layers, and the output that will be one equation, and what I can change is the number of hidden layers. I will keep what the software um, let's say suggest, and check how good is the simulation and the final uh, modeling. So basically what I have here now, I have already my data split in training, validating, testing data. I have some models here to training. I have different training algorithms that I can use. I accept this um, training model here, and of course there are a lot of technical discussion, mathematical discussion, but in the end what I'm going to do in practice way is to see how the model answer based on the mean square error and the regression. If I get something higher than 9%, it's a good result. So let's train the data set and see what the mean error is predicted. So I've got good result here. 97% of the training data set, 99% for the validation and test. And then, of course, I can check how are the regression methods. So here we are the regression methods. So for the training data sets and the total data set, I've got 97% of correlation of the targets and predict targets data and predict the data, the outputs. And here I have the equation that I can use as a target. And then, of course, based on this equation, I can predict the new remaining useful life as I demonstrated before. So since this model have a very good results, of course, if I look on the validation and the test data fit that's already mentioned before, we have a small sample here. That's why and here we have a very good adjustment of the data because the sample is very low. But of course, I will use one of these two uh, regression equation two based on my target. I will predict my remaining useful life. Okay, so that's the principle here. So I also have this summary of my let's say my model, and I have different number of I have different information addition. How long does it take? It was very fast. 9 epochs, that means 9 iteration, 9 process feed forward, back, forward, complete iteration. And the other points that I have here are the different information that I have for concerning the training and so on. So another graph that I can see is the performance of the training. As I mentioned before, we have the training data set, validation data sets, and test data sets. Then we can see the minimum number of epochs. For example, if I got the validation data set, I just needed 3 to get the minimum error. But if I consider a test data set, I need to have 5 epochs to get the minimum data error. And then that's demonstrate the number of simulation for each data set that I need to get to achieve the minimum error and have the best fit function. So now that I have the regression, the next step is to validate the model. And to validate the model, we can input the data. So I don't need to, of course, adjust the network size. I'm happy with the values that I've got. And now what I'm going to do is to validate by using new data set and see how is the error that I've got from a new data set. So um, we go we're going to neural network here. We go to validation. Now I will get from a new data set from, that's a totally new sample. Now I have a compressor 4, a new compressor with new values of degradation, with the, let's say, vibration in the shaft, and also, let's say, um, degradation progression, signature values. And I need to, again, to input the targets that I have for these data sets. So let's just go to neural network and validation. So here I have the target values for remaining useful life that I expect to achieve. So that's one of characteristic of neural network. I need to have the targets, one values, to in the end apply for my network. So here we are ready to test the neural network. We can see that we did not get a good correlation in our test, and that is we need to apply. So just let's come back here again to input the data. So here we are. Okay. And let's get the validation remain useful life here. Okay. And that's what I've got from the test. So the correlation, the regression, I did not give a good correlation. I can see here the correlation is low. So that means this data is not well fitted for the previous model. But of course, what I can do in the end is to run again the method by using these new data sets and predict and perform a new model specifically for this new data, a new neural network that will apply. And then I can do that for different compressors that I want to do, have one particular neural network that fits better to its data that I want to use. So definitely do that. And then, of course, in the end, I can import this different information, the code, for example, for my previous model. So here are the codes. I can use this code or import another data, okay? So let's consider that we've got in this case that we do not achieve a good test by using different data sets. So what I have to do now is to come back to some steps here. And now what I've got to do is to get this new data set here. Let's just import, to be sure that we import the proper data. So what we're going to do is to get this proper data from our data set. Here we are. And the proper, let's say, targets data. Okay, so what I'm doing now, since I performed the test and did not get a good value for the new data set by using the previous neural network, I'm building a new neural network for the new data that I have. So that's what I'm doing now. And then, of course, by using that, I go for the similar step. I split my data set in 70% for training and 50% for validation test. I use 10 neurons, hidden neurons here. Then what I'm going to do is to train my model and see which are the correlation that I've got between the targets and the predicted value. So we can see by doing that I achieve very better correlation that's using the previous neural network. So then I can do that if I do not can use data from the previous neural. I cannot use a previous neural network for a new data. I can use uh, define a new neural network for this new data set. That also I can do that. It's not too much work. It's very simple to do that, and you see. And then in the end, I get a very high correlation between the target data and the predicted data, and that is the targets remain useful life and the predicted remain useful life. And then of course I can use again this equation to predict a new the further remain useful life. Okay, so that is the end of the case study. That we demonstrated the case of regression based on neural network. We have the regression neural network um, methodology, this case description in my new book, Artificial Intelligence for Maintenance 4.0. You can find this information in my new book. And then you can also uh, go in ECC websites and go to the online training, of course. And thanks for your attention. If you have some question, please send your question, and it will be my pleasure to answer.